Hey, welcome back to the channel of Roller Coaster with Math. Today we are tackling a fascinating topic in linear algebra, solving overdetermined systems using the least squares method. Ever wondered how to handle a system with more equations than unknowns? That's where least squares come to the rescue. Let's dive right in. So here's the system we are going to work with. X plus y equals to 2, x minus y equals to 0, and 2x plus 3y equals to 7. This is an overdetermined system because we have 3 equations but only 2 variables, x and y. Usually this means there's no exact solution, so our goal is to find x and y that minimize the error. Minimize the error. A times x minus b square. So first, let's express this system in matrix form. Ax equals to b. So we have A, one, negative 1, and 2, 3. X, 2 vectors, x and y. Our b equals to 2, 0, and 7. So our goal is to solve x to find the least squares solution. We use this formula. X equals to A transpose times A. The inverse of A transpose times A times A transpose times B. This formula minimizes the squared error, A times x minus b square. And gives us the best approximate solution. So let's first compute A transpose times A. From the original matrix A, we know that the transpose of A is given in this form: 1, 1, 2, and 1, negative 1, and 3. So, A transpose times A now is 1, 1, 2, 1, negative 1, 3 times the original matrix A, 1, 1, 1, negative 1, 2, 3. Let's compute this. 1 first row times the first column, 1 times 1 plus 1 times 1, and plus 2 times 2. And then first row times second column, we have 1 times 1 plus 1 times negative 1, then plus 2 times 3. And then next second row times first column, 1 times 1 plus 1 times negative 1 plus 3 times 2. And then second row times the second column, 1 times 1 plus negative 1 times negative 1 plus 3 times 3. What do we have? 1 plus 1 plus 4 equals to 6, and 1 plus negative 1 equals 0, and plus 6 equals to 6, and 1 plus negative 1 plus 6 equals to 6, and then 1 plus 1, 2 plus 9 equals to 11. Okay, this is the result that we get for A transpose times A. Now let's compute the A transpose times B. We have A transpose times B equals to 1, 1, 2, 1, negative 1, and 3. B is 207. So we calculate this matrix. First row times the column, we have 1 times 2 plus 1 times 0 plus 2 times 7, 1 times 2 plus negative 1 times 0 plus 3 times 7, 2 plus 14 equals to 16, and 2 plus 21 equals to 23. Okay, this is the result for A transpose times B. Now we solve X equals to A transpose times A, the inverse of A transpose times A times A transpose times B. First, we compute the inverse of A transpose times A using the formula for A2 by 2 matrix inverse. So inverse of A transpose times A equals to 1 over the determinant of A transpose times A times the matrix D, negative B, negative C, and A. Now the determinant of A transpose times A equals to 6 times 11 minus 6 times 6. Which is 66 minus 36 equals to 30. Then the inverse of A transpose times A equals to 1 over 30 times 11 6, negative 6, negative 6, which is okay. We to compute the x, and x from the formula we have the inverse of A transpose times A and times A transpose times B. So we got the inverse of A transpose times A, which is 1 over 30 times 11, negative 6, negative 6, and 6. And then times the A transpose times B, which is 16 and 23. Now we can compute this. 1 over 30 times 11 times 16 plus negative 6 times 23, and then negative 6 times 11 plus 6 times 23 equals to 1 over 30 times 176 minus 138, and negative 96 plus 138 equals to 1 over 30 times 3842, which equals to 1.27 and 1.4. This is our solution for x. So the least squares solution is approximately x 1.27 and 1.4. This means the best values for x and y that minimize the error are x approximately equals to 1.27 and y approximately 1.4. And that's it. We used the least squares method to solve an overdetermined system. This technique is widely used in statistics, machine learning, and data science, so mastering it is super valuable. So if you found this helpful, hit the like button, subscribe, and let me know in the comments what topic you want me to cover next. Thanks for watching, and I'll see you in the next video.